Hello everyone, welcome back to the Chemostat video series on biological CSTRs. In this video, we want to continue talking about how we experimentally derive our KD rates as well as this Yx by S maximum. It's the production coefficient of cells with respect to the substrate, and of course we want to find this KD. So the question is, where do you find KD? Well, KD is found in this mu g, and mu g equals to d plus KD. Well, originally speaking, mu g equals to mu net plus KD, but due to the cell balance, mu net equals to d. So the net rate of production of cells equals to the dilution rate under steady state conditions. So we can substitute this d plus KD into our equation above. So d over Yx by S apparent. So this is experimental data. This is something you adjust. So it's equal to d plus KD over Yx by S maximum. Now with this, it's a lot more simple. We can simply divide everything throughout by d. So divide throughout by d, then you get 1 plus KD by d Yx by S maximum. So on the left, on the right hand side, the first term, which is on the left, anyway, the first term will be as such, and the second term will be 1 by d into KD over Yx by S maximum. And here you can see already that there's an equation starting to form. So okay, so you have this thing being your so-called y, or the bisca, I think. Yeah, the vertical axis, this should be plotted, the dependent variable, and this 1 by d, which is 1 by the dilution rate, or in fact the residence time, tau equals to v by f, d equals f by v. So this is the residence time, the average residence time of the particles in the chemostat, and that will be KD over Yx by S maximum plus 1 over Yx by S maximum. So this what you see here, we call it the maintenance coefficient, which is m. So conveniently we just call it m, the maintenance coefficient. So this is the y, this is the x, this is the m, and this is the c. So in the standard y equals mx plus c linear relation, this is what you get. So if you plot 1 over Yx by S apparent, and that you can get from getting S naught minus S, which you can measure, divide by X, the outlet concentration of cells, which you can also measure, and you vary the dilution rate, you'll be able to get some kind of plot here. And of course there'll be some error points, and then you get the slope, which is KD over Yx by S m, and the intercept, which is 1 over Yx by S. Okay, so that's how you experimentally determine your KD and this value. So after you get the slope and this value, you should be able to get Yx by S the maximum, and you find KD after that by doing some simple substitution. Anyway, that's all I have for you this video. Hope that was helpful. I'll see you in the next video. Bye bye.